Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi. Tonight I'll be doing the review for test 2, which I'll be giving this Thursday online. Now, the review I'll be doing today, the slides you'll see are located in D2L. However, there's something I need to remind you about. If we look at D2L, and if you, on the left, click on lectures, now where's the review? Well, you have to scroll all the way to the bottom and see where it says load more. Well, you got to click on that. And now it loads more. And when you scroll down, you'll see test number 2 review, both as a Word document and a PDF file. And I'll be using this for today's lecture, or really review. So let's get started. All right, test number 2, the first part I'll go through is an alcohol. An alcohol is an OH group, hydroxyl group on an R group. How do you name it? You find the longest chain with the carbon with the OH group on it. Name it as an alkane. Drop the E, add OL, and if it's acyclic, you need a number. If it's cyclic in a ring, no number, because in my class, that will always be carbon number 1 with the hydroxyl group. Now, there's one exception, and that's a benzene ring with a hydroxyl group. It's an alcohol, and IUPAC, in their infinite wisdom, took the old name and used it, because they said, we're not going to get those chemists, organic chemists to change. They've been using this for centuries. Therefore, this is called phenol. All right, you should know common names for alcohols. And how do you name it? For simple alcohols, you name the R group as the alkyl group it is and add the word alcohol at the end. Now, you should remember rubbing alcohol, which is 70 to 90% the common name, isopropyl alcohol, also known as 2-propanol, and water. I don't know why they call it rubbing alcohol, but you can get anywhere from 70 to 90%. I keep both in my house, 70 and 90%. Now, how do you make an alcohol? Otherwise known as synthesis of an alcohol. Remember, ROH is alcohol. But before I do that, let me just remind you, where can you find alcohols? Well, rubbing alcohol is one place. Not that I'm implying you should ever imbibe it, but hard spirits, beer and wine, also have alcohol. My favorite, vodka. I'm a vodka. My grandparents were Russian. I wonder where I picked up vodka. Don't know. But anyways, vodka has the alcohol. Other hard spirits have alcohol. Also, gasoline contains up to 10% alcohol. If you go to any gas station here in the Chicagoland area, you'll see by the pump, there's a sign that says this gasoline contains up to 10% ethanol. And it's the same gas molecule that's in hard spirits, but don't drink gasoline, that will kill you. Please don't. But the good stuff, Absolute or Grey Goose, you know who also has good stuff? The French version of vodka at Costco. That's probably Grey Goose, but I don't know for sure. All right, how do you make an alcohol? Well, if you have a double bond, add acid and water. Remember, water, think of HOH. You break the pi bond, one carbon in a double bond gets CH, the other gets COH, and it follows Markov-Nikov's rule. The carbon with the most hydrogens in the double bond gets the H, the other one gets the OH. Now, reactions of alcohol, first one is dehydration, meaning removing water, HOH, H2O, water. And here, if you have a double bond, oh, what am I saying? An alcohol, I got ahead of myself. an alcohol reacted with H2SO4, sulfuric acid, and heat, you'll form a double bond. And this formation follows Zaysev's rule. And Zaysev's rule, another great Russian like Markovnikov, organic chemist, Russian organic chemist, is you get the double bond between the two carbons that have the most carbon atoms attached to it. You get the double bond between the two carbons that have the most carbon atoms directly attached to it. Let's take a look at this. This is a little tricky. And if I were to ask on a test, give the organic product or products are the following 3 points each, what would you do? Well, remember at this point, you should always look at a molecule and say, what's different? What's not carbon? What's not hydrogen? Should get your attention like that. And also, what's not a carbon-carbon single bond? And here we have an oxygen, a hydrogen, and a carbon, and alcohol. But I know for this reaction, I'll need an adjacent carbon, one next to it, with a hydrogen. And if I add H2SO4 and heat, the little triangle, think a little flame on top of a candle or Bunsen burner, heat, I'll get a double bond, and it follows Zaysev's rule. Now, one of the carbons in double bond is the carbon with the hydroxyl group. The other carbon is adjacent carbon attached to that carbon with the hydroxyl group that has at least one hydrogen. And if we look at this molecule, there are two choices, A and B. Now, if we take and remove the hydrogen from A and the hydroxyl group, what molecule you get? Well, you break carbon-carbon single bonds, and the answer is no. On your friend for test 2, 3, 4 in the final, how many bonds to carbon? 4. And do you break carbon-carbon single bonds? No, except for combustion in this class, no. So I have 4 carbons across. I still have my methyl group here. And this is the carbon with the hydroxyl group. This is the carbon with the hydrogen. So I'll form a double bond there. And I'll put in the hydrogens because I know there's 4 bonds to carbon. All right, now if I lose the hydroxyl group here and a hydrogen from B, between this carbon and the carbon with the hydroxyl group, I'll form a double bond. Do you break carbon-carbon single bonds? No. So I end up with 5 carbons like that. And now I'll put in my hydrogens. And the question is, which is the right product per Zaysev's rule? Well, now you have to use your higher math skill and say, how many carbons are directly bonded to the carbons of the double bond? Well, up here, 1, 2, 3. So the answer up here is 3. If we look at this one, we only count carbons directly bonded to carbon double bond. This one. And the answer is 1. So now you got to use your real high level math skills. which is larger, 3 or 1? And time's up, hopefully I'll pick 3. And the correct answer is A, would be the product you get. Now, in real life, you get a minor and major product, but I've made your life easier. I'm just asking you what's the product, meaning the major product. So the answer would be A. Again, you lose the hydroxyl group and a hydrogen and a carbon attached to the carbon with the hydroxyl group when you react an alcohol with sulfuric acid and heat, and you form a double bond between those carbons, and it follows As's rule. You get the molecule that has the most carbon atoms directly bonded to the carbons of the double bond. All right. By the way, for those who came in late, the file I am looking at and have on the screen right now is located in the lecture section of D2L, but you have to click on load more to see the bottom part of that folder. D2L is old. Instead of showing all of it, you got to do that. But you have to. All right, let's look at some more general reactions. If you have an alcohol reacted with HX, hydrohalogen acid, where X is going to be chlorine, bromine, or iodine, you replace the hydroxyl group OH on the carbon that has that OH group with the halogen. Now, since HX could react with a double bond, someone came up with another reaction, and this is if you take an alcohol and react it with thionyl chloride, SOCl2, you replace the OH group on the carbon with the OH with the halogen, chlorine. And I've worked with this stuff. It's nasty stuff, but it works so well. Now, next I talked about oxidation. And oops, hold on one sec. All right, everybody's up to speed. I always forget to look at the chat board when I'm deep into review time. All right, now I will never ask on a test or a final what type of alcohol it is, but when you have one R group on the carbon with the hydrox group, that's a primary alcohol. Two R groups, which can be same or different, that's why we have R and R prime, it's a secondary alcohol. If you take a primary alcohol and oxidize it, you lose the hydrogen here and form a carbon-oxygen double bond. You break carbon-carbon single bonds? No. And you get an aldehyde. We'll talk about aldehydes a little later tonight. And this O in a bracket is a general way organic chemists use to denote oxidation. I'm not asking you to learn the different oxidation reagents like potassium permanganate, sodium dichloride, chromate, potassium dichromate, and there are others. I'll just use that. Thank you, Dr. White. You're welcome. Now, if you take a secondary alcohol and oxidize it, same thing happens. You lose a hydrogen here, form a carbon-oxygen double bond. In this case, you get a ketone. Later on tonight, and if you haven't watched the videos, I hope you have, Dr. White and Mother Nature love aldehydes and ketones. And you should know this. Now, tertiary alcohol has no hydrogen on the carbon with the OH, and it cannot be oxidized. In the alcohol lab, I think you're doing this week, you'll learn that. But listen carefully. Let me listen carefully. On my test, on my final, if I ask you give their organic product or products, I will never have the correct answer being no reaction. If I ask you to give the products, there's going to be a reaction. So never on my test or final put down when you're asked to give the reaction products, no reaction. because I didn't like that when I was a student. Come on, you're asking me what reaction products? Why are you putting down no reaction? Ugh. Remember, I teach by my golden rule of teaching. I don't do what I don't do to my students what I didn't like done to me when I was a student. And yes, I can still remember that was a long, long, long time ago. All right, so primary alcohol oxidized to an aldehyde, secondary alcohol ketone. Now, next thing I talked about were thiols. Thiols is the sulfur equivalent of an alcohol. Instead of ROH, you have RSHS being sulfur. Now, the two things you should know about thiols, one, they stink. And I mean, they stink. If you've ever been by an animal or just outside where a skunk left loose, their defensive weapon is water and a mixture of two thiols. And water doesn't think it's the thiols. Ugh. Now, I talked about that awful tragedy happened in the mid 1930s in Texas, where a school blew up and killed a lot of children and teachers because there was a natural gas leak. And at that time in 1935, methane, natural gas, is odorless. It's still odorless, methane. However, because of that tragedy, a thiol, T-butyl thiol, is put into natural gas so you can smell a leak and protects us. I remember I had a leak outside of my house. I had a worker there and he came in and said, you got a gas leak out here. And I said, no, I got the gas company. Luckily, it was a tiny one, but he was able to smell it. He was working there at the gas meter. But you should know natural gas smells because the thiol is put in there. Next, we talked about ethers. Ethers are an oxygen with two R groups, the alkyl groups bonded to it, R and R prime. And I didn't ask you to learn, by the way, I didn't ask you to learn any nomenclature for thiols. For ethers, most people just use the common name, so I asked you to learn that. Name each R group as the alkyl group it is. And then add the word ether at the end. Like diethyl ether is probably the most widely used ether. Now, there's only one reaction I asked you to learn, and that's the Williamson ether synthesis. And that's where you take an alkoxide, RO minus, Na plus, react it with an alkyl halide, R prime X. Here, X can be chlorine, bromine, or iodine. And you form an ether and a salt. NaX if it's Cl chlorine, sodium chloride is or sodium bromide or sodium iodide. Now, the oxygen here bonds to the carbon with the halogen on it. The oxygen here bonds to the carbon with the halogen on it. And let's take a look at that. And if I were to ask on a test, give the organic product or products are the following, what do? Well, you look for what's different. And the first molecule, oxygen minus with an R group on it, carbons, and a sodium cation. That's an alkoxide. And here, second molecule, carbon, what's different? A halogen on a carbon. And that's an alkyl halide. Oops. Got ahead of myself. Remember, X can be chlorine. In this case, it's bromine. or iodine. And what you get, now I'm going to put down the salt, but you don't have to put that because in this question I'm asking the organic product or products. So what's this? What's our prime? This. Now, remember, this oxygen is bonded to carbon in our prime that had the halogen, which is this one. So do we break carbon-carbon single bonds? No. So I have 3 carbons. This carbon here, which had the halogen, will now be bonded to the oxygen. And my R group here, the methyl, will still be there. I know there are 4 bonds to carbon. And that's one way of writing it. Another way you could have written the same molecule in both cases, you have methyl isopropyl ether. Now, let me remind you, on test 1, I only had one synthesis problem, and that is give the starting materials. On test 2, I think I had 3 of them, maybe 4. When I took organic, but I was taking organic for chem majors, sometimes it was a quarter to test was like that. Oh, they were hard tests. All right, next I talked about epoxides. And the only one I talked about was the simplest epoxide, ethylene oxide, which I've worked with in industry a lot. And I gave you 2 reactions you should know. The first one is if you take an alcohol and react it with ethylene oxide, you form this ether alcohol. This oxygen is bonded to the carbon in R that had the hydroxyl group on it. This oxygen is bonded to carbon in R that had the hydroxyl group on it. Next, instead of reacting 1 molecule or mole of ethylene oxide, what if you react N moles of ethylene oxide with an alcohol? And I worked at a company, we did this. We sold these products. And here you get this polyether alcohol, R, then bracket OCH2, CH2, subscript N. Remember, that's repeating N times. And the N comes from the coefficient here. And remember, the hydroxyl group is outside the bracket, not inside. Now, these 2 reactions, I will never give a synthesis reaction problem. It's not fair. Dr. White doesn't like to be Dr. White always tries to be fair to my students. And therefore, these 2, you should know how to give the products, but I will never give them in a synthesis question. All right. Time to have some fun. And let's talk about aldehydes and ketones. By the way, like I said earlier, Dr. White and Mother Nature love aldehydes and ketones. My PhD thesis dealt with aldehydes and ketones. My first US patent, my knowledge of aldehydes I used to come up with new molecules made from aldehydes. And my last patent that I got, US patent a number of years ago, that used ketones and my knowledge of ketones. Dr. White loves aldehydes and ketones. They've been good to me. I've been good to them. All right, aldehyde, carbon, double bond to oxygen. On the carbon, double bond to oxygen has a hydrogen and R. That's an aldehyde. Ketone, carbon, double bond to oxygen. The carbon double bond to oxygen has 2 R groups or carbons. They can be the same or different. That's why we have R and R prime. Now, how do you name them? For an aldehyde. Before I do that, I'm going to skip down to the next right here in red. You'll understand why in a second. You should know What is a carbonyl group? I'll say it again. Listen carefully. You should know what is a carbonyl group. You should know how to describe it with a drawing and with words. A carbonyl group is not a functional group, but a carbonyl group is a carbon double bond to oxygen. And other things are attached to this carbon. That's double bond to oxygen. And you describe it, carbon atom or just a carbon double bond to an oxygen atom or oxygen. And Dr. White loves carbonyl groups. They've been really good to me. I've been really good to them. If somebody asked me, what kind of chemist are you? And I was being totally honest with them, I would say only one answer. I'm a carbonyl synthetic organic chemist. Again, carbonyl synthetic organic chemist. And a carbon double bond to the oxygen is called a carbonyl carbon. So why did I do that? Because how do you name these? Find the longest chain of an aldehyde that has a carbonyl carbon. Name it as an alkane. Drop the E, add Al. No numbers needed because the carbonyl carbon in aldehyde is always one. It rocks. It really does. But again, find the longest chain with the carbonyl carbon of the aldehyde, name it as an alkane, drop the E, add Al, no number because that's always going to be one, and the rest of the substituents like methyl, ethyl, isopropyl, N-propyl, T-butyl, and N-butyl, you name like you always have with a number and a name. All right, you can't have an aldehyde in a ring. You can't. It's impossible. So let's move on to ketones. Ketone is a carbonyl group with two R groups. How do you name it? Now, for a cycle, for both ring or not in a ring, you find longest chain or ring that has the carbonyl carbon in it. Name it as an alkane or a cycloalkane. Drop the E, add ONE. Again, drop the E, add ONE. And for acyclic, you need a number. And that number is the carbonyl carbon. It should be the lowest number, meaning closest to the end of a chain. For a ring, no number, because always, there's no exceptions I know of, the carbonyl carbon in a ring of a ketone is always one. Everybody knows that, so we don't put that down. Hopefully you've been keeping up with the practice problems, but let's do give the IUPAC name for this molecule. And how do you do that? You look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Should get your attention like that. Ooh, an oxygen double bond to carbon. Carbon's here and here. This is a ketone. And what's the longest chain? 1, 2, 3, 4, 5, either 6 or 6 here. So 6 carbons is the longest chain. And you should know that's hexane. But it's a ketone, drop the E, add O-N-E, hexanone. But it's acyclic, and therefore, if I counted from this side, it's the carbonyl carbon is carbon 2. If I started here, it's 1, 2, 3, 4, 5. And you have the high level math skills, which is a smaller number, 2 or 5, and times up. Hopefully you pick 2. So that's 2-hexanone. Are we done? Well, as soon as we say 2-hexanone, we have the, oh, look, it's your old friend, the methyl group. and it's on carbon 5. So this would be 5-methyl-2-cyclohexanol. And there are two types of nomenclature question that will be on test 2, just like test 1. First one is give the IUPAC name for the following. And this one, draw the structure. I'm going to give you time to try it out, and then I'll do it. Your turn to have some fun. And when you're done, give me a thumbs up. All right, looks like everybody's done. I better get to work. How do you decode this to know what to draw? Start from this end. ONE ending. Ketone, if that were E, cyclohexane is a 6-membered ring. And it's a ketone. One of the carbons has a double bond to oxygen. This is carbon 1. You can go clockwise or counterclockwise. I think all of you will go clockwise. Here's carbon 3. It has an N-propyl, 3 carbons. The N carbon is bonded to the ring. And that's how you do ketones and aldehyde. Well, I didn't do an aldehyde, but you got the idea. All right. Now, I asked you to learn 2 common names. On common names, I'll never ask you what's the common name. I'll give you the common name and ask you to draw it, because you're going to encounter those in labels of things you buy. First one is formaldehyde. Formaldehyde is the simplest aldehyde. Even though I normally have R and H, R can be a hydrogen too, and this is formaldehyde. When used properly, it's an important chemical. My last patent, I used formaldehyde along with a ketone. I worked for a company years ago that was the largest producer of formaldehyde in the world. Then Borden Chemical, now called Hexion. And remember the dangers, this will never be on a test, about formaldehyde in certain wood products, especially those that used to come from China. I think they've improved, but still be careful. The other one, the simplest ketone, is this molecule, acetone. Nobody ever calls this 2-propanone. It's acetone. And remember, acetone is one of the 2 molecules for nail polish remover. See, I took all my nail polish off. Dr. White will never be a hand model on TV. But anyways, no, I don't polish my nails. But acetone is one of the 2 molecules, I'll teach you later on the other one, that's used to remove nail polish. I already talked about this, but I'll do it again. You should know what is the carbonyl group, how to draw it, and how to describe it with words. Carbonyl group, carbon double bond to oxygen, carbon atom or carbon double bond to oxygen atom or oxygen. All right, now these 2 we've already done, and that is primary alcohol oxidized, you get an aldehyde. Secondary alcohol, you oxidize, you get a ketone. Do you break carbon-carbon single bonds? No. And so these are these 2 reactions. Now, next reaction is the Friedel-Crafts acylation reaction. That's where if you take benzene, and this is called an acid chloride, carbonyl with a chlorine and R group, aluminum trichloride, and you form an aromatic ketone. And aromatic ketones make good sunscreens. And I talked about other uses. And this is one of those special reactions where you make a carbon-carbon single bond. Very important, very special. Now, next 4 reactions, I will never give a synthesis reaction, but you should know how to give the products. And later on, I will show you later in the semester, way down the road, how Mother Nature uses these reactions in our daily life. Yep, later on, we're going to get into real good stuff, what Mother Nature does in our body and our plants around us and everywhere. Exciting stuff. But anyways, now, I use the shorthand that organic chemists use because we're lazy. This right here, if R prime is hydrogen, it's an aldehyde. If R prime is carbon, it's a ketone. R double prime will always be carbons. Now, if I react that with 1 molecule of an alcohol, H plus is acid catalyst like sulfuric acid or others, but I always use H plus. You get this molecule. Now, keep your eye on the carbonyl carbon, carbon double bond oxygen. That's where the fun is. What's attached to it stays attached to it. And then this changes. The OR bonds to the carbonyl carbon, and the H from the alcohol goes on the oxygen. And you get a hemiacetal, hemiketal, which I didn't ask you to learn the names of, but I'll use them anyways. Again, I'll never give a synthesis for this one. Now, if you take, oops, made a mistake here. I won't have time to correct it on D2L. There should be an H there. Now you know Dr. White's human. I am not a robot. But anyways, you take an alcohol, a ketone or aldehyde, reacted now with 2 molecules of alcohol and an acid catalyst. You lose this oxygen, comes off as water. But anyways, same thing up here. But on the carbon that had the carbonyl group, what was attached to it, R prime or hydrogen or and R double prime is still there. And now you get 2 OR groups from the alcohols. Now, a special case, which my advisor, Dr. Rush's advisor, Dr. Herbert Storer, I think it was at I can't remember what university in New York he was at. But anyways, he came up with a special case where if you take an aldehyde or ketone, react it with this alcohol, ethylene glycol, has 2 alcohols in the same molecule, acid catalyst, you get the same reaction, except R is connected to itself. You don't break carbon-carbon single bonds. This bond is this bond. This is R. This is R. It's like up here, except there's a bond between there you keep. And this is a way of protecting aldehydes and ketones when you're doing other reactions or in the molecule, something I don't do in this class really much, a little later on in sugars. But in real life, to make certain complex medicine molecules, molecules that are used in medicine, you have more than one functional group. And sometimes you don't want to lose that ketone or aldehyde because you're going to react another reagent, part of a functional group, with a molecule that would destroy those aldehydes or ketones. So you put on a protecting group. All right. Now, once you have a hemiacetal, if you add acid and water, you get back the aldehyde or ketone plus the alcohol you would have gotten to make that hemiacetal. Again, this breaks down to give this molecule, the aldehyde or ketone, plus the alcohol you would have used to make that, which was this reaction. And we'll learn later on, this reaction is one of the 2 reactions I'll teach you how your body breaks down carbohydrates. The good stuff in life, French fries, pizza, bread, potatoes, rice, the good stuff. Now, when you're looking at this, how do you know what to do? Well, there's only two molecules or functional groups where you have two single bonded oxygen to the same carbon. This is one of them. And you get back the aldehyde or ketone plus the alcohol you would have used to make that compound. The other case is where you have an acetal or ketal. And this is also one of the reactions your body does in your stomach. I'll get real personal later on, talk about what's going on in our stomachs. A lot of organic chemistry. But anyways, here, if you take acetal or ketal, again, this is one of only two cases where you have two oxygens single bonded to the same carbon, and you add acid and water. H plus is acid. Remember, in our stomachs, we have HCl. And you get back again the aldehyde or ketone plus the alcohol you would have used to make that. Now, as you've learned by now, I never, ever asked you to balance an equation in my class. We don't. Organic chemists most don't most of the time, except when we're calculating charge weights, how much you have to add of this and this to make so much of this, which is something I don't teach in this class. I think most undergrad classes don't even teach. When you get into industry, you better learn how to do that quick. But you really get two alcohols, but you don't have to put that in there. That's why I have the tiny little two with the quotation marks. You want to go ahead. If you don't. Again, these four reactions plus the special case, I will never give a synthesis problem. All right, let's go to a fun reaction. And this is my hero, one of my heroes in organic chemistry, the great French organic chemist, Victor Grignard, who won the Nobel Prize. I think it was somewhere around 1905 to 1910, give or take a few years. And the first reaction is, if you take a alkyl halide, react it with magnesium metal, you form the Grignard reagent, RMGX. Remember, that's the carbon with the halogen will now be bonded to the magnesium, and the magnesium will be bonded to the halogen. This is wrong. Wrong. Nothing exists. Remember, the carbon is bonded to magnesium, and the magnesium is bonded to halogen. And the halogen can be chlorine, bromine, or iodine. Now, one of my favorite reactions in chemistry is the Grignard reagent, reaction, which Dr. Grignard won the Nobel Prize for the reaction before in this one. And this is so special because this is one of those reactions where you can make a carbon-carbon single bond. You take a ketone or aldehyde and react it first with the Grignard, second with acid and water. That's what 1 and 2 mean, separate steps. You form a carbon-carbon single bond between the R triple prime and the carbon. What was the carbonyl carbon is now an alcohol. And this is one of those special reactions where you can form a carbon-carbon single bond. So special. Let's take a look at one of them. I'll never give a synthesis problem. And the question is, give the organic product or products for the following. So you look at this right here, what's different? Ooh, oxygen, double bond to carbon, with carbon's carbon. This is a ketone. Now, it could have been an aldehyde, but it's not. Then what's different here? Carbon, carbon, what's not carbon, what's not hydrogen? Get your attention like that. Ooh, magnesium, iodine, and a carbon. And this is a Grignard reagent. Remember, X can be chlorine, bromine, or iodine. In our case, it's iodine. Second step, H plus means acid, water. Hopefully you all know H2O. And keep your eye on the carbonyl carbon, because that's where the fun is. What's attached to it will still be attached to it, our prime or hydrogen, our double prime. And this opens up to an alcohol. And this R group attacks that, organic chemists are violent, attacks that, and forms this carbon-carbon single bond. The carbon in our triple prime with the Grignard is the carbon. This carbon here will be bonded in our triple prime. So here's our carbonyl. What's attached to it, our prime methyl, our double prime methyl, OH. And what's my R triple prime? These carbons. Which carbon of those three carbons has the magnesium halide on it? Iodine, the end one. So you break carbon-carbon single bonds, you still have three carbons. The end one is there. Remember, there's 4 bonds to carbon. And that's the alcohol you make. That's a pretty complex molecule, which later on I'll show you how that can be used, maybe not that exact molecule, to make things like, are you ready for this? Perfumes. Yep, perfume is organic chemistry. All right, let's look at a couple of simpler reactions. Remember, this is a pi bond, a double bond between 2 atoms, 1 pi bond and 1 sigma bond. And you learned with carbon-carbon double bonds, you add hydrogen and a catalyst, you can break the pi bond, and each atom of the double bond gets a hydrogen. Well, that happens here with an aldehyde or a ketone. And reacted with hydrogen and catalyst, so nickel, platinum, or palladium. You break the pi bond, and each atom of the carbonyl double bond gets a hydrogen. And our prime or H, excuse me, and our double prime come along for the ride. Now, if you had a double bond in this molecule, that would be hydrogenated. If you didn't want to, Dr. H.C. Brown of Purdue in the late 40s discovered it, but it took a couple of decades before they finally gave him a Nobel Prize for it, which he deserved, and he finally got. He came up with a new reagent, LiAlH4, lithium aluminum hydride, second step acid and water, and does the same thing. It breaks the pi bond, and each atom of the double bond carbon oxygen double bond get a hydrogen. Now, lithium aluminum hydride will only attack carbonyls, carbon double bond to oxygen, not carbon-carbon double bonds. That's why it's very useful. In my PhD thesis research, I used it a lot. And finally, one of my favorites, the aldol condensation. This involves doing an enolate anion. Remember, the alpha carbon, the carbon bond to the carbonyl has acidic protons. You can pull it off with a base like NaOH to form an enolate anion and one of the aldehydes. In my special gift, I'll show 2 of the same aldehyde for this aldol condensation. This attacks the carbonyl carbon, forms something special, something rare. Carbon-carbon single bond opens this one up to an alcohol. Everything else comes along for the ride. And as I said in my videos, not this reaction, but for my PhD thesis, I did a lot of research in enolate anions and aldehydes and ketones, and I'm a world expert in it. They're so nice. They're lovely. Now you know I'm an organic chemist. All right. Hopefully you've all do the practice problems. And before I let you go, and I'll stick around if anybody has any questions, let's do something fun. Let's play that fun game, circle and name the functional group, 2 points each. And I put the S in there because there could be more than one. And let's just do 2 of them. And I'll let you have some fun first, and then I'll do it. So let's play that fun game, circle and name the functional groups, 2 points each. Your turn. And give me a thumbs up when you're done. Remember, I'm not asking you to give the IUPAC name or common name. Excuse me. I'm just asking you to circle and name the functional group, 2 points each. All right, my turn. So how do you play this game for this chapter or this test too? You look for what's different, what's not carbon or what's not hydrogen. Should get your attention like that. And if you look at the functional groups, we're talking about OH, oxygen. Ooh, here's one here. And we got a carbon with an OH group. I'm going to show this. You don't have to do that, but it's an alcohol. Oh, another oxygen. And this oxygen here is double bond to carbon, a carbonyl group with a H and an R. And what's this? An aldehyde. Now let's look at B. Ooh, right up here. Oxygen with a carbon and a ring right here. And that carbon has carbons here in the ring and there. And they're just connected together. And what is this? It's a ketone. Are we done? No, there's another oxygen here. It's got a carbon here in the ring, carbon here and here, outside of the ring, a methyl group. And what is this? It's an ether. Are we done? Oh no, one more. Why, I threw everything in here but the kitchen sink. Oxygen double bond to carbon with a hydrogen carbons here. What is that? Again, this is an aldehyde. And that's how you play that fun game. Circle and name the functional groups, 2 points each. You don't have to put the general structure. You just have to put the names, the circle part of it. And with that, I'm done. I'm going to stick around if anybody has any questions. And in a little while, within the next hour or two, I'll post this video in my YouTube channel. And let me remind you, Thursday at 8 a.m. or maybe even a little earlier, I'll send out the password for the password protected PDF file for test 2 that will be located in the assignment area of D2L. You'll have until Friday, 8 p.m. to upload your answer as a single PDF file. Make sure you check your file before you upload it, that you've answered all the questions and you scanned all your answers into your PDF file, either with a scanner like I have there, or your cell phone using something like Cam Scammer. And I think I have take up to 4 whatever hours, take whatever time you need, as long as you get it uploaded on time. If we were face-to-face in a classroom, you'd have 55 minutes. My test, if you've done the practice problems, and for online, if you watch the videos, you should be done in about 40 minutes, because I don't write a test that only the smartest person in the room, which in science would be me, math too, was the only one who could finish. That's not fair. And with that, I'm going to stick around, but I'm going to do my favorite say goodbye, sign off, and that's gehen gesund. Remember, in Yiddish, that means go in hell. And guess what? COVID's still out there. Unfortunately, I found out a student of mine, her family last week at another school came down with COVID. I still wear a mask when I go out into supermarkets and all that, but that's me. So I'll say gehen gesund, I'll say goodbye, and I stole that from Granny to Beverly Hillbillies. And with that, I'll stick around if you have any questions, and I'll stop the recording.